Okay, so we're going to do 1.4a. We'll call it fractional expressions. Okay, the first topic we're going to talk about is domain, which is a humongous topic that will come up for the rest of the year, like in every chapter. Okay, so it's really important we understand domain. We're going to spend the next several days talking about it. So let's define it. Domain is the set of x values for which an expression is defined. Okay, so we're going to talk about domain first. I guess we'll call this example 1. Find the domain and write your answer in interval notation. Last year, did you learn about interval notation, parentheses, and brackets? We talked about that. Okay, so we're going to talk about that some more. Remember that parentheses mean that the value is not included. And this replaced like an open circle. Remember an open circle on the number line? Okay, now instead of the open circle, we use a parenthesis. It means that the value is not included. A bracket means the value is included. And this replaced the closed circle. Okay, so let's look at polynomials first. Okay, let's say, for example, we had x squared plus 3x plus 4. Okay, now remember, when you're talking about domain, you're thinking about what x is allowed to be, or sometimes you can think about what it's not allowed to be. So is there anything that I'm not allowed to plug into this expression? Like, think about negative numbers, positive numbers, zero, fractions, like anything. Just think about, you know, big and small, whatever. Any type of number. So you can also think about the graph, right? If you have the graph of this, let's see, we have a parabola, right? It points upward. So what kind of x values are you allowed to plug in? Can you plug in negatives? Yeah, right? Can you plug in positives? Yeah. Can you plug in 0? Yeah. So you're allowed to use anything, right? This was all real numbers. Remember that? But we don't write all real numbers anymore. We have to use interval notation. So this looks like negative infinity to infinity, both with parentheses. This stands for all real numbers. Now, let's talk about why we use a parenthesis and not a bracket. So a parenthesis means that number is not included, right? Or you can't define that number. So thinking about infinity, there's no way to define infinity. We don't know what number that is. It goes on forever. So because of that, anytime you talk about negative infinity or infinity, you have to use a parenthesis every single time. Okay? Let's look at another example. If you have x to the 5th plus x cubed plus x. Okay, so again, you want to think about, can I plug in negative numbers, positive numbers, 0? Is there anything that's going to make this undefined? No, there's not, right? Any polynomial that you're given, no matter what, will always have a domain from negative infinity to infinity. It can be anything, okay? Everything is included for x. So negative infinity to infinity is always the answer for those. That's like a gift I'll give you on a quiz and ask you what's the domain of this, okay? Because there's not a lot of thinking. It's just all real numbers. Anything works. Okay, so those are easy. Let's take a look at rational expressions. Okay, let's start with x plus 2 over x plus 5. Okay, so now I want you to think about, is there anything that x is not allowed to be? Nick. Yeah, negative 5. And why can't it be negative 5? Exactly. So if I plug in a negative 5 here, I get 0 in the denominator. 0 in the denominator is undefined, correct? So what I did there, although this one is easy to see, what I did was I took the denominator, I set it equal to 0, and then I solved. And I got that x was equal to negative 5. But what I just solved for was the value that x is not allowed to equal. So before, you might have wrote your answer like this: x can't equal negative 5. Anyone do that? Okay, but we can't do that anymore. So we have to give our answer in interval notation. So now what we want to be able to tell our reader is, like, x can be anything except the number negative 5. So anytime you're writing an interval notation, you always start at the smallest number on the left. So what is the smallest number x can be in this case? Negative infinity, right? It could be negative 1,000,000, negative 8 trillion. Okay, so negative infinity is the smallest number that x is allowed to be. And we want to use a parenthesis there because you can't define negative infinity. So now we're going to go all the way. Imagine the number line, okay? So here's our number line. Negative 5 is the only thing we can't equal, right? So it was like before we put an open circle there. So it was like everything here and everything here. Yes? So now we have to tell the reader, okay, once you get to negative 5, you got to jump over it. Okay, so now I'm going to put a comma and a negative 5. Because negative 5 is not included, you have to use a parenthesis. Okay, what's the largest number x can be? Positive infinity. The largest number always goes on the right side. So now I'm going to join this with a union. That's a union symbol. It means and. And I'm going to start back at negative 5 with a parenthesis. And I'm going to go all the way to positive infinity. So this open circle here is represented when I have these sets of parentheses, okay? And then I'm jumping over that value. So it goes all the way up to negative 5, and then starting back after negative 5, like negative 5.00000001, now all the way to infinity. Okay? So that's how you write it in interval notation. Let's look at another one. X plus 5 over x squared minus 5x plus 6. So this one, it's not real clear at the very beginning. I can't just look at it and say, okay, x can't be negative 5 like I did here, right? I have to do some work. What is the work I need to do? Yeah, you need to factor it. So you're still taking that denominator, setting it equal to 0. Okay, and now we factor. So, using guess and check, you should come up with x minus 3 times x minus 2. Remember, this is where you're going to use a zero product property. You set each of those equal to 0. You solve. You get x is not allowed to equal 3 and 2. So now there's 2 values that x can't be. Okay, I want you and your partner to try to come up with interval notation. So talk it over and Tell me what you think. Okay, so who can volunteer what they came up with? This is a tough one. You've never seen this before, so it's okay. Just take a risk. Sophia. Okay. Anybody come up with something different? Natalia. Okay, so I'm just going to cut to the chase. One of these is right, and one of them is not. So now I want you to go back to your partner and talk about which one's right and which one's not, and why. Okay, let's do a vote. How many people think the top one is right? Oh, I know you're out there. How many of you think the bottom one is right? Okay, some people just aren't sure. They're just going to go with the crowd. So let's see. Madison, why do you think the bottom one is right?
Because you can still have numbers between 2 and 3.
That's right. See, the thing is 2, 3. It seems like there's just 2 numbers there that are listed that aren't included, right? But 2, 3 includes all of the numbers between 2 and 3. So 2.01, 2.54, 2.999999999. If you don't include those, like this one isn't including it. So if you don't include those, you're skipping all of those numbers. And actually, there's infinitely many numbers within there, isn't there? Okay, so this is not correct. This one is the correct answer. So you've jumped over the 2, you've jumped over the 3, everything else is included from negative infinity to infinity. Okay? So, just a quick note here. In order to find the domain of rational expressions, you are going to set the denominator. Equal to 0. Okay, and then you solve. Okay, now let's talk about roots. So let's start out with the square root of x minus 8. Okay, so we're still thinking about domain. So now we're still trying to think about, okay, what are the numbers that are allowed to be x? Or you can think about, like, what is x not allowed to be? Either way. So, what do you know about a square root? Can't take the square root of a negative. So everyone agrees that anything in here has got to be positive, right? Okay, that's a good start. Can you take the square root of 0? Think about the rules of a square root. It says you have to have 2 inside to take out 1. What's 0 times 0? 0. Can you take the square root of 0? Yes, there's 2 zeros inside. You can take out 1. Okay? So you can take the square root of 0. So then what does that mean in terms of my answer within here when I simplify this? It has to be greater than or equal to 0. Because that's going to make it 0 or positive, right? So I'm going to take this x minus 8 and set it greater than or equal to 0. When you solve this, you just have to add the 8. So that means that x has to be greater than or equal to 8. Think about that when you plug in the numbers. So if I plug in an 8, I have 8 minus 8, I get 0. I can take the square root of 0. That's good. And then numbers bigger than 8 are going to give me a positive solution here that I'm allowed to take the square root of. So now how do I write this in interval notation? Remember, the smallest number goes on the left. So what's the smallest x can be? 8. So that's where I start. Is it included or not included? Included, so I get a bracket there. What's the largest x can be? Infinity. So it's going to infinity, and I have a parenthesis there. Okay? Next one. Cube root of x minus 8. Okay, so now we're talking about the cube root. So now again, we're going to think about what are you allowed to take the cube root of? Can you take the cube root of a positive? Yes. Can you take the cube root of 0? What's 0 times 0 times 0? 3 inside, you're allowed to take out 1. Okay, so you can take the cube root of 0. Can you take the cube root of a negative number? Yes, because there's a negative 1 inside, right? Negative 1 times negative 1 times negative 1 is negative 1, and you can take the cube root. So that means you're allowed to take the cube root of anything. So then what does that mean about its domain? Right, it's anything. It's negative infinity to infinity. That's like another gift. Okay, if you get a cube root, you know it's negative infinity to infinity. Anything works. All right, you and your partner are going to talk about this one. X plus 1 over the square root of x minus 2. Okay, so who wants to volunteer? What did you come up with? Saad, what did you guys come up with? Just take a risk. It's okay. Maybe it's right, maybe it's not. It's okay. Uh-huh. Okay. Who came up with something different? Morgan.
I got a bracket.
Okay, so same thing but with a bracket. Okay. Who came up with something else? Anyone come up with this? Okay. Okay, so now we got to talk about which one is right. Can this one be right? No, because now you're saying all these negative numbers are included. What happens when you plug in a negative here? Right? It's undefined. Not allowed. Can't happen. So it's between these two. So really what we're trying to decide is 2 included or is it not? Because this is the same thing except one says it is and one says it's not. So can you plug in 2? Okay, so I plug in 2. I get 2 minus 2, I get 0. The square root of 0 is 0. We all agree you can take the square root of 0. But where is the 0? It's in the denominator. Are you allowed to include the 2? No. Tricky, isn't it? We're following the rules of the roots, right? You set it greater than or equal to 0, but you have to think about where it's located. So this one is not allowed. This is the correct answer. This is saying a little bit bigger than 2 on will work. Okay? Good job. It was worth taking a risk. Oh, it's all her. Okay. Okay, so let's make some rules here. If you have an even root, you set it greater than or equal to 0. Okay? let's make a note though, unless it's in the denominator. So like example C. Okay, then you just set it greater than 0. Maybe make yourself a note there. You set this x was greater than 2. So x minus 2 was greater than 0. If you have an odd root, then every single time you get negative infinity to infinity. Okay, now let's talk about what is an even root, what's an odd root. So an even root can be, the square root, the 4th root, the 10th root, the 20th root. Any root that's even, that's how you find the domain. Any root that's odd, whether it's the cube root, the 11th root, the 5th root, if it's an odd number, it's always going to be negative infinity to infinity. Okay, this is a huge, huge idea. It doesn't feel that big right now because, we just went over a few examples. We're going to talk about this as the days continue because they get more difficult. But now we're going to shift gears and we're going to start talking about simplifying. So let's call this part simplifying rational expressions. And we're going to make some steps to follow. So when you approach a problem like this, the first thing you're going to do is you are going to try to factor the numerator and the denominator. The second thing you're going to try to do is cancel any common factors. And then finally, step 3, you have to include the domain restriction. Okay, so let's take a look here. I guess we'll just say simplify as our direction. What is this? Example like 3, 2, 1? I don't know. Lost track of my labeling here. 2? Let's label it example 2. Okay, so if you have 15x squared over 10x. Okay, this is a rational expression, right? It's a fraction. There's no equal sign. So if you have this, what should you do? Think about that GCF, right? So between 15 and 10, everyone agrees it's a common factor of 5. So we're going to get 3 over 2. Then we have to simplify our variables. So x squared over x, right? You just have to subtract exponents when you're dividing. So 2 minus 1 leaves us with x to the first in the numerator. Okay, now, thank you. Now, we're not quite done. So we've simplified. Okay, we've canceled out the common factors. Okay, that's all done. But what we haven't done is included the domain. Now, when you include the domain here, you can just include it like you did last year, where it's like x cannot equal whatever values. So when you look at this, 3x over 2, or 3 over 2x, it's the same thing, right? When you look at that, hopefully you're thinking that's a polynomial and there is no restriction, right? It's negative infinity to infinity. X can be anything. However, you have to go back to the original. What was x not allowed to equal? 0. Because if it did, this became undefined. Okay? So even though you can't see it anymore, you have to list it from the beginning. So we're going to say x cannot equal 0. And that's our final answer. All right, let's try another one like that. X squared plus 8x minus 20 over x squared plus 11x plus 10. Okay, so step 1 says we have to factor the numerator and the denominator. So we're going to factor using guess and check. When I do that, I get x, let's see, plus 10 times x minus 2. right? That gives me that positive 8, negative 20, over x plus 10 times x plus 1. Okay, so that's step 1. We got to factor. Once we've done that, now we're going to look for those common factors in order to cancel. Now, the only reason I'm allowed to cancel right now is because there's multiplication going on. Okay? So x plus 10 is going to cancel there. Another little tip, if you're having trouble factoring either the numerator or the denominator, you can always look to whichever one that you have factored for little tips, right? Chances are there's going to be a common factor between them, okay? So now these have canceled. I'm left with x minus 2 over x plus 1. But I have to include the restriction, so I have to go back. When I canceled out this x plus 10. Right? So that meant that x could not equal negative 10. Agree? So I have to include that. So x cannot equal negative 10. Now, do you also agree, though, that x can't equal negative 1? But we can see that still in our answer. So we don't have to list it. You can list it, but you don't have to list it. Okay? If it's there, we see it, it's redundant to list it. All right? We recognize it. So we're good. So that would be it. Questions on B? All right, now we're going to try some specific operations. So we're still simplifying, but this time we're going to talk about multiplying. So let's say x squared plus 3x minus 10 over x times x squared plus 2x over x squared plus 7x plus 10. Okay, so step 1, we're going to factor. So I also want you, while we're doing step 1, to think about how do you multiply fractions together. So when you multiply fractions, don't you just multiply straight across, numerator times numerator, denominator times denominator, right? So this really becomes one big numerator, one big denominator. All right, so let's do that. I'm going to factor while I combine them into 1. So x squared plus 3x minus 10 factors to x plus 5 times x minus 2. And x squared plus 2x is x times x plus 2. All of this gets multiplied together in one big numerator. Now I'm going to take those denominators, I'm going to factor them, I'm going to combine them into 1. So I have x times x plus 5 times x plus 2 when you factor x squared plus 7x plus 10. At that point I've factored, I've multiplied them together. Now I want to look for those common factors that can cancel. So I have this x plus 5 canceling, my x cancels, my x plus 2 cancels. Lots of canceling here. The reason why you're allowed to cancel is because you're multiplying all of these binomials together, okay? Finally, we're only left with this x minus 2. Now, if you just look at this right now, it looks like there's no restriction at all, right? It's a polynomial. X is allowed to be anything. However, if you go back, what was x not allowed to be? Negative 5, negative 2, 0. Notice how I listed those from least to greatest. Okay? Couldn't be negative 5, couldn't be negative 2, couldn't be 0. That's your final answer. Let's try another one of those. X cubed minus 1 over x plus 2 times x plus 2 squared over x squared minus 1. So before we do anything, we have to factor, right, and then join those numerators and denominators. So here we have a difference of cubes. So right away, I'm expecting you to remember that special factoring pattern. So we're going to get x minus 1 times x squared plus x plus 1 times x plus 2 squared. I'm just combining the numerators. You can write this out as x plus 2 times x plus 2 if you want. In the denominator, I'll have an x plus 2. And then looking at that second denominator, we have a difference of squares here, right? So it factors to x plus 1 times x minus 1. Okay, so I cancel my x minus 1. I cancel one of these x plus 2's in the numerator and the other one in the denominator. And now I'm left with x squared plus x plus 1 over x plus 1. Whoopsie, I lost my x plus 2. Now you're not going to multiply this out. Okay, you're going to leave it in factored form because it's easier for me to check. And then we, again, want to think about, is there a restriction that needs to be listed? So was there canceling that happened? Yes, right? Negative 2 and positive 1. And take a look here. Right now I can see that x can't be negative 1 as well, but you don't have to list it because you can still see it. If you do list it, you're not going to get marked down. It's just not necessary. Okay? How are we doing on the multiplying? Today is a lot. Today is a lot of information coming your way, and we're not done yet. Okay? Let's talk about division. Okay. Dividing, which is equally as fun as multiplying. Okay, how about x plus 2 over 5 times the quantity x minus 3 divided by x minus 2 divided by 5 times x minus 3. Okay, so let's go back to like 4th grade when we started talking about fractions, right? Take a trip down memory lane. What are the rules when you're dividing fractions? Flip the second guy and multiply, right? You just multiply by the reciprocal. I learned that phrase when I started teaching pre-algebra here. I was like, what does this mean? What is this? Flip the second guy. But now I get it. I get it now. But yeah, we're going to multiply by the reciprocal. So it's really the same thing that we were just doing, except we have one extra step. So I'm going to change this to x plus 2 over 5 times x minus 3 times 5 times x minus 3 over x minus 2. All you have to do is multiply by the reciprocal. So the same steps apply. You factor, you combine numerators and denominators, you cancel. So we're going to get x plus 2 times 5 times x minus 3 over 5 times x minus 3 times x minus 2. Our 5 times x minus 3 is going to cancel. We're left with x plus 2 over x minus 2. Now with the restriction, this 5 times x minus 3 canceled, right? So if you think about setting that equal to 0, what happens with the 5? Goes away, because when you divide by 5 on both sides, we get x minus 3 equals 0, right? So x is not allowed to be 3, and that's the restriction you want to list. Good news, we're on the last one. Okay, x squared minus 1 over x divided by x minus 1 squared over x. So this looks intimidating. right? There's like a compound fraction going on. There's like 3 division bars. This is a little intimidating. But doesn't this mean x squared minus 1 over x divided by x minus 1 squared over x? Isn't that the same exact thing I just did? Right? It's just written differently. It means the same thing. So you still have to multiply by the reciprocal. So I'm going to take that x squared minus 1. I'm going to factor it. Right? It's a difference of perfect squares. So x plus 1 times x minus 1 over x. And then instead of dividing, I'm now just going to multiply by the reciprocal. So I'm going to change this to multiplication of x over x minus 1 squared. Same thing I just did, except it looks different. So here, my x's cancel. Here, I have 1x minus 1 canceling. I'm left with x plus 1 over x minus 1. What is x not allowed to equal? 0. Positive 1 can be listed. It doesn't need to be listed. It's obvious. Well,